Myself is Chaitanya. I'm currently working as a software engineer at Tech Mahindra Private Limited. So today's session, I will be presenting you the analysis which I performed on the Exploratory dataset as part of the dataset foundation project for the UPX. Yes. So this is a Jupyter notebook which I have designed. So all the analysis and all the observations were also highlighted in this notebook. Yes. Basically, as part of the exercise, I have tried to use all the concepts which were taught in the foundation course, and I will be guiding you like what are the what are the concepts which I use and what are the observations were made. Yeah. So we can see that initially I have imported the basic Python packages which are required for the analysis, and also I have placed the dataset in my local repository by giving the path I have like declared it using your underscore path, and I'm using the read underscore CSV to import the file. So after the import, I just given the command called info so that I can get like how many columns are there and how many rows are available. Yes, so there are 19 columns and 336,776 rows are the entries. Yes. So if you go to the head of 10, I have given used this head of 10 command to just see the top first 10 rows, how they are, and to just to get the basic understanding how the data set and what are the information was given. Yeah, so we can see like it is basically I would say it is the itineraries on each day, or how many itineraries were been originating from the New York City airports. So basically that information was given. Similarly, the tile also I have given just to see like what's the difference from the head. So if you can see here, like there are few values which are missing, so they are coded as NA. So I have just used the command describe to just see like from the each attribute side how the values have been uh, like varying actually, to be honest. So from this we can say that the year is actually quite constant, so that is the reason I have dropped this field as well. And also I have dropped the tile number because that is nothing but the flight number. As part of this analysis, I believe this number might not be useful for me at any cost, so I just dropped these two particular fields. So coming back to the describe analysis, from this I have understood that for the arrival delay and the departure delay, the mean value and the median value are quite varying. So as part of the filling the values, I have used a new function called as interpolate, uh, which is the best when it comes to the dealing with the missing values. So I have like used these functions for all of the attributes which are having the missing values, and later I have run the info again, so you can see like all the columns are having the same number of rows. Yeah. So I also have interpreted the heat map for this particular data set. And from this, you can clearly understand that the distance, sorry, the scheduled departure time, the departure time are quite correlated with the hour, so which is quite obvious because the departure time and the hour are should be quite correlated, to be honest. Yes, and apart from that, you can see that the A time was again correlated with distance. So basically, the more the distance, the more the A time. The less the distance, the less the A time. So these are the observations were made, and the same has been also like highlighted in the particular PPT where what are the observations were made. So I have also used one more command, that is one more package, that is Pandas profiling for this analysis. So just try to see what are the observations were inferred from this report, and also compare with the observation which I made. So here also it is clearly mentioned. If you go to the next slide here, what are the major observations are quite similar with what I have made. So here also it mentioned that the time is dependent on the hour and vice versa similarly. Yes, and again in this pandas profiling, it has given the total list of missing values and also like how many data types are there overall if you see among the 19 ones. Yeah. So Okay, so basically this analysis have provide I mean like formed few business questions. Based on that, I have performed this analysis. So there are totally eight business questions here, which are like more on the like maximum delays, minimum delays for a given month, and again the same the delays across the carriers, and again the airport where we are seeing the maximum delays and minimum delays, and again calculating the flight speed, etc., etc. So I will be again going back to the Jupyter notebook, and we will be like starting to see the observations one by one. Okay, the first one is like delay calculation at the destination location. So first I have like printed out the what are the origin and the destination here. So origin measures majorly are from New York City airports, and when it comes to the destination, I would say they are across the US. So totally there are like 105 destinations listed here, and we can see the like the code of the each airport in the below array. Yeah. So as the first step, I have created a new data set by grouping by with the destination and using the arrival delay as the aggregate. So yeah, I just printed out the like first five rows for this particular table, and it is something like this. So again, we are trying to see like the we are using the cutoff here, like that is 200. That is what I basically the cutoff threshold. You can say it's more of a threshold where. So what we have made here is, so we have currently 105 airports, which are the destination airports. So we have set a basic criteria that is to go under this analysis. It should at least go down like completed 200 itineraries minimum. So at least it should have 200 flights arrived throughout the year. So that is a basic condition which I have kept, and based on that, I have performed the rest of the analysis for this particular business question. So I just plotted a bar diagram where you can clearly see the airport, which has a maximum number of arrivals is the TUL, and the minimum arrival is the airport which is having the maximum arrival delay, it is TUL, and with the minimum arrival delay is SMA. Yeah. So that is the same. It is inferred here, and I have printed. And coming to the origin locations, so there are three origin locations. So it is quite evident from this particular table. So EWR is having the maximum departure delays, and LGA is having the minimum mean departure delays. So overall values here calculated are the mean values. So basically the mean average delay for the year 2013, that is the value mentioned here, and the 39.44 is in minutes. So that is the unit which was used. So the next topic is regarding the airlines with maximum and minimum delay. So if you go this in this thing, we have created one more data set where we are taking carrier as the group by, and we have used both departure delay and arrival delay for the aggregate. So we have got the mean overall delay for the year 2013 for various departure and arrival delays. And we haven't used any threshold in this case because the number of carriers are very less. So we have considered all of them, and we have to see which one has having the maximum mean delays and etc. So that's the reason we have calculated the total mean delay. So the formula is pretty simple. We have this is a summation of the departure delays and arrival delays overall the year. So there's a new column here listed out, and we have parallelly gone with the plotting these observations, and we have seen that it was quite the mean values for arrival delays are quite at nearly 15 minutes, and whereas for the departure delays around the mean delays around 15 minutes, whereas the arrival delays more around like below 10 minutes. So this is quite from this you can quite infer that the departure delays are the major contributor when it comes to a total delay for a given itinerary or overall year if you consider. The same is plotted here. If you can see the departure delay graph is much above higher than the arrival delay graph in most of the cases. Okay, so these are the basic observations which you made. So, but basically we have calculated is the airlines, the carriers or airlines which is having the maximum mean departure, arrival and overall delays. So in this, you can see U is having the maximum departure delay, whereas the F9 is having the maximum arrival delay. So since the departure delay is major contributor for the total delay, you can see the same in the total mean delay as well. So this is the one part. The other part is like we have calculated the minimum delays as well. So in this as well, a carrier is having like the departure, the mean delay with 4.9 minutes, whereas arrival delay with the least is having the AS with minus 9.8 minutes. So we can say that it is quite over punctual. That is, it is quite early when it comes to the destination points. Yeah. So at the finally we have like want to check curious about the percentage how much the departure delay is contributing to the total delay, that is 61.86%. So coming to the next block, that is the destination airports, which are most busy and the least busy. That are basically the busiest and the less busiest airports here. So on the analysis, this is pretty straightforward. We have calculated the size here for the dataset created above. That is the um, basically the number of itineraries, I mean number of arrivals happen for the particular destination overall year. So on this analysis, we have come under the ORT is having the maximum arrivals observed, whereas LGA, since it is a New York City airport, and the data is from New York City, there will be like very less chances that a flight travel between the airports. There are only one. Yes, but there is a one flaw with the max function. Since the max function, minimum function and max function will only return the like the last value. So we are getting LGA as the output. But if you see the like header, we can see both LEX and LG are having the one value. So we can see the minimum. Okay, the least busy is LEX or LG airport when it comes to the arrivals. Yeah, from the data set. Okay. So the next part again, the it comes to New York City airports, which are the most busy and least busy, where EWR is considered the most busiest airport, which is having one like 20,000 overall the year, and LG is the minimum least busy. Yeah. So our next business question goes with the months where we have so the maximum minimum delays. So again we have like grouped by using a month and the departure delay as aggregate. And you can see here the one more data set has been created and we have calculated the total delay as well, how we have calculated in the case of carrier. So we have plotted the graphs for the arrival departure delay and arrival delay. And again, if you see the both the graphs, you can say that during the month of June, not June and July, we are observing the maximum delays. But among these two, July is having the maximum number of delay observed. And when it comes to the month of the September, we are observing like the minimum delay. That is from the graph. So again, we have plotted one more bar diagram where we are seeing all the three delays, total, arrival, and departure delays correspondingly. So finally, the observations were quite clear as well. So from the graphs, what we observed, and it's the same. So month of 7, that is July, is having the maximum delays observed, whereas minimum delays were observed on the month of the September. Yeah, so that is a mean of 44 minutes for the maximum delay and mean of 5.5 minutes for the delay on the month of September. So we have like the highest and the lowest we have calculated as well, or like on the overall on the data set for the year of 2013, when we have observed the maximum delay, that is on 9th of January for HA airline, and minimum was for VX airline during the May 7th. Yeah, that is one more observation we have made. So the next coming to next business question, that is a month during which we have observed airports which are most and least busy. So basically, we have again plotted using the carrier, and we have observed that during the month of July, the airports are very busy. When it comes to the month of February, they are least busy. We can say that February, since it after 2 months of Christmas, we are seeing less traffic, to be honest. So the last topic is the fastest and slowest airlines, which we have observed. So basically, for this, we have created a new column that is nothing but the flight speed. So we have used a simple formula, that is the flight speed is equal to distance by a time. So based on that, we have created this particular new column, and we have like created one more data set where we have grouped by using the carrier and aggregated with the flight speed. So we have plotted this, and we can observe that this particular graph from the plot, we can observe HA carriers. We have observed the maximum airline speed for overall year on an average, and for UV we have observed the least. So the same again we have plotted for like for overall month each airline how the speeds are varying, and you can see as the year is going we are seeing the flight speeds are increasing. They're more like a parabolic type, parabolic arrangement where we are seeing the price suites are increasing their maximum during the month of July and again they are decreasing. So we can say during the peak season, that is July, we are seeing the carriers are operated at the highest speed so that they can reach the destination. But still we have observed that there are major delays. So that is the we can observe that how much peak we can was observed on the July month. So the next analysis is on the flight speed, the maximum recorded. So this the maximum flight speed recorded was on the 7th of December. The for the carrier B6 was the least recorded for the US carrier on 27th of July. That is 8 miles per minute. Yeah. Then the last analysis, that is the airline with the maximum mean speed recorded, is HA airline, as the same we have inferred from this graph, and the minimum was the UV. Yes, the same has been interpreted in this particular PowerPoint presentation where we have like detailed explain like how the what are the observations made and what are the business questions that are answered. So basically, what are the free data frames we created as part of this analysis are listed here. There are totally 8 data frames has been created for analyzing the each business question. So at the last we have highlighted like for each business question what was the observation observed, what are the observations made, the maximum daily departure delay was observed on TUL. SNS recorded the lowest travel delays. EWR is having the most number of departures, whereas LJ is having the least number of departures. Maximum delays observed were on month of July, where the minimum was September. While coming to the lowest mean speed and highest mean speed, we are listed again. So months during which airports are most and least busy as well we have highlighted. This July it is most busy and the February is the least. So these are the basic questions which we I thought like can be asked based on the data set was provided. Well, this mostly will cover all the sides of the data set which was provided. Yeah, and thank you for giving me this opportunity. Have a nice day. Thank you.